Okay, hi everyone, welcome back to this live stream for Windows Server 2003. So I'm going to share my screen. Okay, so Chapter 4, Managing IP Security, Microsoft exam objectives covered in this chapter. Monitor network protocol security. Tools might include the IP security monitor, Microsoft Management Console, MMC, Snap-in, and Kerberos support tools. Troubleshoot network protocol security. Tools might include IP Security Monitor, MMC, Snap-in, Event Viewer, and Network Monitor. The ability to control network traffic is a key part of system administration. Many organizations want to protect their network traffic from eavesdropping and tampering, but it's been very difficult to do so because of the obstacles involved. Interoperability is the most obvious hurdle, but there are a lot of subtle pitfalls associated with trying to secure network traffic in a robust yet easily managed way. The Internet Engineering Task Force (IETF) addressed this problem some time ago, and the result was the Internet Protocol Security Extensions (IPsec). IPsec is a set of extensions to the basic Internet Protocol IP. The IPsec extensions allow secure communication over unsecure Internet Protocol IP and is not a replacement for IP. In this chapter, you will learn how to install and configure IPsec and how to use the default security policies. You'll also learn how to define your own security policies and filters to customize the level of protection available to computers on your networks. Understanding how IPsec works. The original specifications for IP made no provisions for any kind of security. That wasn't accidental. It stemmed from two completely different causes. One was the expectation that users and administrators would continue to behave fairly well and not make serious attempts to compromise other people's traffic. The other was that the cryptographic technology needed to provide adequate security wasn't widely available or even widely known about. As the internet expanded, it became clear that robust authentication and privacy protection were desirable, but they weren't included in version 4 of the IP specification, which is currently the adopted standard. As the installed base of IP-capable devices grew, so did the complexity of devising a security protocol that wouldn't interfere with the operation of those devices. Finally, in the late 1990s, vendors began releasing products that incorporated the IP security extension, known better as just IPsec, into IP version 4. The whole idea behind IPsec is that it operates at the network layer and that users and applications never need to be aware of whether their traffic is being carried over a secure connection or not. IPsec terminology, there are clients and servers, but that's a little misleading. Any Windows 2000 server, Windows XP, or Windows Server 2003 machine may be an IPsec client or server. An IPsec client is a computer that attempts to establish a connection to another machine, and an IPsec server is the target of that connection. By choosing appropriate client and server settings, you can fine-tune which computers will use IPsec to talk to each other. IPsec provides two services: a way for computers to decide if they trust each other, authentication, and a way to keep network data private, encryption. The IPsec process calls for two computers to authenticate each other before beginning an encrypted connection. At that point, the two machines can use the Internet Key Exchange (IKE) protocol to agree on a secret key to use for encrypting the traffic between them. This process takes place in the context of IPsec Security Associations SA, which you will learn about later in this chapter. As if that weren't enough, the Windows Server 2003 implementation of IPsec explicitly supports the idea of policy-based security. Instead of running around changing security settings on every machine in a domain, you can set policies that configure individual machines, groups of machines within an organizational unit or domain, or every Windows 2000 XP or Server 2003 machine on your network. When you use IPsec to encrypt or authenticate connections between two machines called end-to-end mode or transport node, because network traffic is protected before it leaves the originating machine, it remains secured until the receiving machine gets it and decrypts it. There's a second application using IPsec to secure network traffic that's being passed over someone else's wires. This use of IPsec is called tunnel mode because it's used to encrypt traffic to pass over or through a tunnel, usually established by the layer 2 tunneling protocol L2TP. IPsec fundamentals. IPsec has two separate features, authentication and encryption. You can use them together or separately, and each feature has a number of options and parameters you can adjust to fine-tune security on your network. Authentication protects your network and the data it carries from tampering. This tampering might take form of a malicious attacker sitting between a client and a server, altering the contents of packets, referred to as a man-in-the-middle attack, or it might take the form of an attacker joining your network, impersonating either a client or a server. IPsec uses an authentication header, AH, to digitally sign the entire contents of each packet. This signature provides three separate benefits. Protection against replay attacks. If an attacker can capture packets, save them until a later time, and send them again, then they can impersonate a machine after that machine is no longer on the network. This is called a replay attack. IPsec's authentication mechanism prevents replay attacks by including the sender's signature on all packets. Protection against tampering. IPsec's signatures provide data integrity, meaning that an interloper can't selectively change parts of packets to alter their meaning. Protection against spoofing. Normally, when you hear about authentication, it refers to the process of a client or a server verifying another machine's identity. IPsec authentication headers provide authentication because each end of a connection can verify the other's identity. Authentication protects your data against tampering, but it doesn't do anything to keep people from seeing it. For that, you need encryption, which actually obscures the payload contents so that it can't be read as it goes by. To accomplish this, So for that, you need encryption, which actually obscures the payload content so it can't be read as it goes by. So to accomplish this, IPsec provides the encapsulating security payload, ESP. ESP is used to encrypt the entire payload of an IPsec packet, rendering it undecipherable by anyone other than the intended recipient. ESP only provides confidentiality, but it can be combined with AH to gain maximum security. In the following sections, you will see how IPsec is integrated into Windows Server 2003, the specific details of IPsec negotiation process. IPsec and Windows Server 2003. Microsoft's IPsec implementation is actually licensed from and was written by Cisco, which guarantees good compatibility with other standard-based IPsec clients. There are some other Windows Server 2003 features that make IPsec more useful, especially group policy. Imagine a large network of computers, some running IPsec, When two computers want to communicate, it would be ideal if they could automatically take advantage of IPsec if both ends supported it. You'd also want to ensure that the security settings you wanted were applied to all IPsec capable machines, Windows NT, and with most other operating systems, that would mean hand configuring each IPsec machine to use the settings you wanted. The situation lies in the Windows Server 2003 group policy mechanism. First, you specify the IPsec settings you want to use on your network. Then each Windows 2000 XP or Server 2003 machine runs a service called IPsec Policy Agent. When the system starts, the policy agent connects to an Active Directory server, downloads the IPsec policy, and then passes it to the IPsec service. You will learn more about the policy agent in the security policies section later in this chapter. Windows Server 2003 adds several new IPsec features that were either not present in or significantly enhanced since Windows 2000. Some of the features simply add extra layers of security to IPsec, but others actually enhance or replace the management and monitoring tools that you would use in the workplace. IP Security Monitor. The IP Security Monitor is new for Windows Server 2003. This tool is now implemented as an MMC snap-in and adds several enhancements to the old version. You can now monitor IPsec information on the local computer as well as on remote machines. View details of all IPsec policies, view generic and specific filters, view statistics, view security associations, customize the display, and search for specific filters by IP address. Stronger cryptographic master key Diffie-Hellman. IPsec now includes support for the much stronger Group 3 2048-bit Diffie-Hellman key exchange. The complexity of this key exchange significantly increases the difficulty of computing the secret key. However, if you require backward compatibility with Windows 2000 and Windows XP, you must use Group 2 Medium, which provides a 1024-bit key exchange. You should never use Group 1 Low. Command Line Management NetSH. You can now configure IPsec using the updated NetSH command, which replaces the IPsec POL.exe tool in Windows 2000. With NetSH, you can script and automate IPsec configuration. Persistent bodies. You can now create a persistent policy for a computer if a local or Active Directory based policy cannot be applied. The persistent policy is always active and cannot be overridden by any other policy. Persistent policies can be applied only by using the NetSH command. Removal of default traffic exemptions. Previously, all broadcasts, multicast, Internet Key Exchange, IKE, Kerberos, and Resource Reservation Protocol, RSVP, traffic was exempt from IPsec by default. Now only IKE traffic is exempt because IKE is required for establishing IPsec secure communication, IPsec functionality over NAT. IPsec ESP packets can now pass through network address translation NAT that allow UDP traffic with a feature called User Datagram Protocol Encapsulation Security Payload UDP ESP encapsulation. IPsec support for resultant set of policy RSOP. Resultant set of policy RSOP is a new feature of Windows Server 2003 that provides the ability to see exactly how the various policies within a domain will apply to a specific user or computer. IPsec provides an extension to the RSOP console that you can use to view detailed settings for the IPsec policy that is being applied. the IPsec negotiation process, Internet Security Association and Key Management Protocol ISAK-MP and the IKE protocol provide a way for two computers to agree on security settings and exchange a security key they can use to communicate securely. In IPsec, a security association, SA provides all the information needed for two computers to communicate securely. The SA contains a policy agreement that controls which algorithms and key lengths the two machines will use, plus the actual security keys used to securely exchange information. Think of this agreement as a contract. It specifies what each party is and is not willing to do. Part of the agreement. There are two steps of this process: main mode and quick mode. First, the main mode, the two computers use the ISAK-MP to establish a security agreement. This is called ISAK-MP-SA. To establish the ISAK-MP-SA, the two computers must agree on the following three things: which encryption algorithm they'll use, DES, triple DES, 40-bit DES, or none, and DES means data encryption standard. Which algorithm they'll use for verifying message identity, MD5 or SHA-1. How connections will be authenticated using a public key certificate, a shared secret key, or Kerberos. Once the ISAK-MP-SA is in place, the two machines can use the Oakley protocol to securely agree on a shared master key. This key, called the ISAK-MP master key, is used along with the algorithms negotiated in the ISAK-MP-SA to establish a secure connection. After the secure connection is brought up, the two machines start another round of negotiations called quick mode. These negotiations cover the following: whether authentication header AH protocol will be used for this connection, whether the encapsulating security payload ESP protocol will be used for this connection, which encryption algorithm will be used for ESP protocol, which authentication protocol will be used for the AH protocol. After these negotiations are finished, the two machines end up with two new SAs, one for inbound traffic and another for outbound traffic. These SAs are called IPsec SAs to distinguish them from ISAK-MP-SA. At this point, Oakley is used again to generate a new set of session keys. The master ISAK-MP key is used whenever new SAs are negotiated. Once the SA negotiation finishes through the communications using the SA are protected using the SA specific keys. The AH protocol provides data integrity and authentication. There are two features that give AH its security. The first security feature is that the packet signature, which is contained in the AH itself, is computed on the entire packet payload and headers. That means that an attacker can't modify any part of the packet, including the IP or TCP UDP header. The second security feature is that AH is placed between the IP header and the TCP or UDP header. This adds further tamper proofing. The ESP protocol is designed to deliver message confidentiality. Take a look at a sample ESP4 packet, figure 4.1, to see how it accomplished this. This packet is more complex in construction than the AH packet because ESP alone provides authentication, replay proofing, and integrity checking. It does so by adding three separate components: an ESP header, an ESP trailer, and an ESP authentication block. Each of these components contains some of the data needed to provide the necessary authentication and integrity checking to prevent tampering. An ESP client has to sign the ESP header, application data, and ESP trailer into one unit, and ESP is used to encrypt the application data and the ESP trailer to provide functionality. The combination of this feature, of this overlapping signature and encryption, provides good security. So I'm going to leave it here this evening for this live stream. Thank you for spending the time with me, and have a good evening.